Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes what p-values are and how to use them to evaluate linear correlation. Let's get started. In previous mini-lectures, we've used critical R values to evaluate claims of linear correlation between two variables in a data set. There's another way to go about supporting the claim of correlation, and that is with something called the p-value. Technically, the p-value is the probability of getting a random chance, a value for R that is at least extreme as the one obtained from your sample data. That's what my Uncle Tom would call a highfalutin pencil neck definition. So let me break this down like a fraction for you. Because the p-value is a probability, it will be a number between 0 and 1 inclusive. This is a property of probabilities that we'll cover later in a future mini-lecture. Now, as a general rule of thumb, p-values above 5% are considered high within a region of non-acceptance, which for our purposes here means you don't have linear correlation. Conversely, p-values below 5% are considered low and within the region of acceptance, which for our purposes means you have linear correlation. Now, there's nothing magical about this 5% threshold. You could use 1% or 10% or whatever you want, really. It's just that 5% is by far and away what is most commonly used. Now, often the problems you work in your assignments will tell you what the p-value for a particular data set is. But you can always use software like StatCrunch to find it yourself as long as you have the data. Let's go back to our shoe print data set to illustrate how we evaluate linear correlation with p-values. The p-value for that data set is 0.071. This is the decimal form of the probability. Converting to percent form gives 7.1%. You just take that decimal point and move it 2 places to the right. We can now compare that with our 5% threshold. Because 7.1% is greater than 5%, we have a p-value that's considered to be high, and so in a region of non-acceptance. We then conclude there is not sufficient evidence to support the claim of linear correlation between shoe print length and height. We can use the same procedure on any other data set. So if we go back and look at our data set for bacteria, the p-value for that data set is 0.006, which is the same thing as 0.6%. We then compare the 0.6% with our 5% threshold. Because 0.6% is less than 5%, the p-value is considered low, and so therefore we have sufficient evidence to conclude that there's a linear relationship between the number of days and the number of bacteria. Notice that we're reaching the same conclusion with p-value that we reached with the critical R value, so whichever method you choose, you should reach the same conclusion. Let's look at an example problem to demonstrate this concept. We'll work at using critical R values and then use the p-value to see whether we reach the same conclusion. Here we have prices for regular and premium gas at 8 different gas stations. You can find the data in our StatCrunch group, but all you need to know for this problem is that we have a linear correlation coefficient of 0.197 and a p-value of 0.6402. Now we're asked, what are the critical values of R and what can you conclude about a linear correlation? Well, remember, you'll typically find critical values of R from a table. Here's our critical R value table. So what's our critical value of R? If you don't remember how to use the table, remember you first find your sample size. Our problem statement says we have 8 pairs of data. See up here in our problem statement, we have 8 pairs of data. So our sample size is 8. We look in the table and find that value right here. Then we just look across the same row in the other column of the table, and there's our critical R value, 0.707. But remember, we have 2 values for critical R, so one's positive and one's negative. Remember, the table just lists the positive value, so don't forget the negative one. Now, that answers our first question. We'll answer the second question by comparing our critical R values with the R value we get from the data. And so here's our number line with our critical R values, and all we need to do now is add in the R value from the data set. What's that number? Well, here in the problem statement, we see the R value from our data is 0.197, which would place it here on the number line. So what region are we in? Well, we're in the region of no correlation, which is the region of non-acceptance. Therefore, we can conclude there's not sufficient evidence to support a claim of linear correlation between the price of regular gas and the price of premium gas. Now, would we reach the same conclusion if we used the p-value instead of critical values? Well, we would. Our p-value is 0.6402, which is 64.02%. Because 64% is greater than 5%, we have a p-value that's considered high and in a region of non-acceptance. And so we conclude, as we just did with critical R values, that there is not sufficient evidence to support a claim of linear correlation. And that brings us to the end of this mini lecture. I hope you found it helpful. As always, you can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.